Hi, welcome to the lecture on artificial neural networks. In the previous lectures, we already discussed that an artificial neural network is a deep learning model which draws inspiration from the neural structure of the human brain. Generally, ANNs are the complex structures which contains interconnected adaptive elements known as artificial neurons, wherein these neurons can perform large computations for knowledge representation. These artificial neurons generally possess all the fundamental qualities which a biological neuron system is possessing. These qualities include learning capability, robustness, nonlinearity, high parallelism, fault and failure tolerance, ability to handle imprecise and fuzzy information, and generalizing ability. Now let us see the core characteristics of artificial neural networks. The first characteristic is nonlinearity, which imparts a better fit to the data. We'll see in the later part of the lecture what is nonlinearity and why nonlinearity is an important property for a better fit to the data. And the second characteristic is high parallelism, which promotes fast processing and hardware failure tolerance. The third property is generalization, which allows for the application of the model to the unlearned data. And the next property is noise insensitivity, which allows the artificial neural networks to accurately predict the values for even for uncertain data and measurement errors. Also, learning and adaptivity allows the model to update its internal architecture according to the changing environment. Let us see the components of artificial neural network. Generally, ANNs are comprised of three core layers, which is nothing but input layer, hidden layer or hidden layers, and an output layer. So we shall see what actual input layer is about. So this is the first layer where it is fed with the inputs or nothing but raw data. So this conveys the information from the outside world to the network, where it gives the information from this first layer to the next hidden layer. Do remember that in the input layer or the first layer, no computation is performed. The nodes just merely pass the information to the hidden layer. Next comes the second layer, hidden layer. So in the hidden layer, the nodes lie hidden behind the input layer. It means they comprise the abstraction part in every neural network. Okay, so they will be doing all the high level computations. All the computation on the features entered through this input layer occur in the hidden layer, and from the hidden layer, these hidden layers after computing transfer the result to the output layer. And finally the output layer is what it is going to do is this layer is going to give us the results of the computations performed by the network to the outside world. In the previous classes, we saw the basic neuron model, and now coming to the artificial neural networks, these networks are comprised of large number of simple elements which are nothing but neurons, and each of these neurons are going to make the simple decisions, and when they are combined they are going to form the artificial neural network where they are going to do complex decisions. Okay, so these complex decisions help us to find the answers in complex problems such as natural language processing, computer vision, etc. So there can be shallow neural networks or there can be deep neural networks. The only difference is that the shallow or non-deep feed-forward neural networks consist of an input layer, and they consist of only one hidden layer which processes the inputs, and the output layer which provides the final output of the model. But coming to the deep neural networks, generally they have 2 to 8 number of hidden layers, where we have input layer. Here you see there are hidden layer 1, hidden layer 2 and hidden layer 3. So most probably they will be having 2 to 8 hidden layers, and then we'll be having an output layer. So this is how a deep neural network is going to look like. Now let's go to the most important part of the neural networks, which is nothing but activation function. So let us consider a neuron. Let us take the output as y, represented by y. So the output y can be represented as the sum of weights and inputs, that is weight into input plus the bias. We have already discussed about what is bias in the previous lecture. So the value of y can be ranging anything from minus infinity to plus infinity. So now the question is that how can we decide whether a particular neuron should fire or not? So activation functions are those which are used to decide when this particular neuron is going to fire. So also the activation function is also known as transfer function. Now let us see the role of activation function in neural network model. As we discussed that the activation function decides whether a neuron should be activated or not by calculating the weighted sum and further adding the bias with it. As we have seen here, see, it is going to calculate the weighted sum of the weight and input and adding the bias to it. And later it is used to determine the output of the neural network, say yes or no, that is, it maps the resulting values in between 0 to 1 or minus 1 to 1 depending upon the function which we are using. So simply activation function can be told as a mathematical gate in between the input which is feeding the current neuron and its output which is going to the next layer. So finally you can say that about activation function that it can be a transformation that maps the input signals onto the output signals that are needed for the neural network to function. So this is how the basic process is carried out by the neuron in our neural networks. So first of all, as a step 1, we will be taking the input and we will multiply it by the neuron's weight, and now we will add some bias to the already calculated weights, and as the third step we will be feeding the result to the activation function which is nothing but f of x, and in the last step we will be taking the output and transmit to the next layers of neurons. Basically there are three types of activation functions. The first one is binary step function, the second one is linear activation function, and the third one is non-linear activation function.